Hi, my name is Yuri and I'm a Maths PhD student at Imperial College London as well as a tutor at the Elite Prep. Today's video is going to be a little bit different to what I've been doing previously in that I am going to be having more of a lesson format where I introduce the concept of options pricing. The goals are the following. Firstly, I want to describe what an option is. Secondly, I want to price an option via a replicating argument. That will be done under a binomial model. By the end of this lesson, you should know exactly what all of these words mean. So without further ado, let's get started. In the market, there are many different types of assets. You can have equities, FX, commodities, and on top of that, a type of asset is also a derivative. A derivative is just a contract, a financial instrument, which is derived from an underlying. So depending on the price of the underlying, you get some price of this financial instrument, and that price doesn't have to be linear. It can be kind of anything you can think of. An option is an example of a derivative. So an option specifically gives the buyer of the option the right, but not the obligation to buy or sell the underlying at an agreed upon price and agreed upon time. So I'll write that down. The specific example I will give is an option on a stock. So let's just draw what can happen to a stock. So here I have axes, I have the time, and I have the price. I also have a stock which moves in some way. And then this time is today. This is just T0. In the future, it can either go up or it can go down. Let's say the price of the stock today is 100. In the future, the stock either goes up to 110 or it goes down to 90. One way of trading in the markets could just be to buy this stock directly and to be exposed to the direct movements of the stock. So either in the future we'll have 110 at time T1. So T0 is today and T1 is the future. Or we can do something different. And this option gives us the chance to do something different if we buy it. So a European call option will do the following. The European call option gives the buyer of the option the right, but not the obligation, to buy the option for an agreed price and at an agreed time. The price for which on which we agree is called K, and that's the strike price. And the time at which we agreed to buy the option is called T, and that's the maturity. The amount that we receive when this option is exercised depends on the underlying price. So it depends on the stock price, right? Because we're deciding at a final time if we want to buy it. We'll want to buy it for the agreed price if the stock exceeds that agreed price, and we'll not want to do anything if it doesn't. So if the stock goes up, I'm going to say CT is the price of the call option, or actually in this case the payoff of the call option, is equal to, in this case, 110 minus K. So if we say K is somewhere between here, 90 is less than K is less than 110, then the call will either be 110 minus K if we reach 110, or it will be 0 if stock reaches 90. Apart from a European call, there is also a European put. So in that case, the European put gives the buyer the right, but not the obligation, to sell the underlying. So naturally, you'd want to sell something if you're selling it for a higher price than what it's worth. we would want to sell the stock for an agreed price K, and we would want to sell it if K is bigger than what the stock is worth in the market. So if the stock reaches 90, we get K minus 90, and otherwise we get 0 if the stock reaches 110. But now, how would we price something like this? We're going to restrict ourselves to pricing in the following environment. We're gonna say that we have a stock. We have a stock. Let's say that the stock, as before, starts at price 100 and it ends at price 110, or it ends at price 90. It has a probability of P of reaching 110, and it has a probability of 1 minus P of reaching 90. So this is our stock, ST1. And because there's only 2 options, we can think of this as just throwing a biased coin. So the coin has a probability of P of being heads. So then we say ST1, if we throw heads, is equal to 110, and ST1, and in fact, I'm not going to have T1, I'm just going to say ST, S little t at heads, and S little t at tails is equal to 90. That's the evolution of the stock. Apart from that, we also have a riskless asset, because we can always just keep money in the bank account, and we have an interest rate, let's say, of 1% if we keep the money in the bank account. So we have 1.01 and 1. So that's the bank account at time 0 is worth 1, and the bank account at time 1 at time t is equal to 1.01, because interest rate is 1%. Okay. Finally, we also have our call option, and our call option behaves in a way which depends on our stock. So our call option at time 0 is something we don't know. So we want C0, we want the price of the call option at time C0, at time 0. But then what we do know is what happens to the call option in the future. We know what the payoff will be if we know what the stock will be. So if the stock, so let's say the call option has K equals 100, so its strike price is 100, and its maturity equals T, then here we will just have 10, because if we recall, the call option is just 110 minus the strike if the stock exceeds 100, so the strike, and it's 0 otherwise. So it's 10 with probability P, because the stock has probability P of moving up. And it's also equal to 0 with probability 1 minus P. Because the stock, the thing which the option depends on, has probability 1 minus P of going down. Great. So the intuition behind pricing something like this is the following. We want to construct a portfolio, so a collection of stocks and investment in our bank account, such that we can reproduce what the call option will give us. i.e., at time t, we want to be able to have a number of stocks, an amount in our bank account, which will be exactly equal to the payoff of the call option. So that was just explained in words, but in a formula, we want, so this is CT heads, and this is CT tails. We want the following. We want CT is equal to PT, and PT is just some collection of stocks. So delta is just some real value. It can be positive or negative. And we also make the assumption that we can buy a fractional number of the stocks, and plus x BT. So BT is just our bank account. It's the risk-free asset. So we want this. And this PT, it can either be PT heads or PT tails. So I will add that on. PT omega. Omega. For omega, either heads or tails. We want this to hold for both cases. But notice, we actually know ST, we know BT, and we also know CT, right? So we have the following. We have CT heads is equal to delta ST heads plus X BT heads. And we also have CT tails equals delta ST tails plus XBT tails. And this is just a system of simultaneous equations. We have two simultaneous equations and we have two unknowns, delta and x. So we just want to solve for these equations. Solving for these equations gives us the following result. Okay, so in this case, we have a delta of a half and x equals minus 45 divided by 1 plus r, so 1 plus the interest rate. So that means that we have that our portfolio is equal to a half ST and minus 45 over 1.01 times BT. However, and this is the key now, because we've said that the call option is equal to the portfolio, and the portfolio is equal to this, but we know exactly how ST and BT evolve. If we have B0 right now, we have BT in the future. If we have S0 right now, we have ST in the future. So this portfolio today would be worth a half S0. So this is in the future. And this is today, minus 45 over 1.01 B0. B0 was just equal to 1. S0 was equal to 100. So that means this is equal to 50 minus 45 divided by 1.01. which is approximately equal to 5.4. So our call option, and PT is P0. So our call option at time 0 must be equal to 5.4. The reason is, if the call option was actually more expensive than 5.4, then we would want to sell that call option, buy the portfolio consisting of a half of a share and this much in the bank account. And then at the final time, they would just counteract. So we would just have nothing happening at the end because what we've earned from the portfolio, we lose from the call option in any case. So they're exactly equal and they counteract. But at the beginning, we would have pocketed the amounts that we gained from the call option. So if CT, if C0 is greater than pi 0, then we sell C0 by pi 0 and we get a positive amount of money in all cases. And on the other hand, if C0 is less than pi 0, we buy C0 and sell pi 0. and then we still have a positive amount of money. Then we'll end up having, so in the first case, we'll have C0 minus pi 0 in the bank account. So after time t, we would have this times the interest rate, and the portfolios just counteract. So it would be plus CT minus pi t, and this is just equal to 0. In the other case, we would have pi 0 minus C0, again with interest. And then we would have, sorry, in the first case, we had pi t minus CT because we bought the portfolio pi 0 and we sold the call option. And in this case, we have that we bought the call option. So we have plus CT minus pi t. And that is also equal to 0 because we have CT is equal to pi t. And this all boils down to, in essence, the fact that we have found a price where there is no arbitrage. So that's the final definition of today. We have priced in such a way that there is no arbitrage. And that is the upshot of this. Okay, so an exercise which I would suggest for you to do, and if you do it, post the outcome down in the comments. So the market which we have is the following. We have S0, we have U S0 is equal to the case where we throw heads. We also have DS0, which is the case where we throw tails. This happens with probability P. This happens with probability 1 minus P. We again have the bank account. B0 equals 1. BT equals 1 plus R, B0. And finally, we have some Y0, which is unknown. And Y0 has the following payoffs. And when it's tails, it's only depending on the stock price when the stock price is tails as well. So this obviously happens with probability P, and this happens with 1 minus P. You can label this as YH and label this as YT. So then I want you to find Y0. So that's the exercise. Thank you very much for watching. Please do post your solutions below if you decide to do it, and see you in the next one.